Okay, again, this is 8th grade. This is part 2 for lesson 3.3. The previous video, I talked about how to find the y-intercept, or the b, in y equals mx plus b. So I'm looking at example 1 here. And it's got a factory, and they've got some welding robots. It says find the welding rate. The welding rate would be the rate of change, or the slope, for each robot. So you should know how to do that now. I showed you that previously. And for the GNX, they give it to you right here. And you can see that the rate of change is 11.2. They tell you that. So in this example, the rate of change would be how fast these robots can weld. And then for this one, they went ahead and did it for you. They picked two points, and they came up with a rate of change of 10.4. So this GNX is obviously faster. Number 2, it says find the initial value for each robot, and they did kind of point out something that's common sense. At 0 minutes, each robot would have performed 0 tasks. So even though this does not give us an x value of 0, you would just intuitively know that at 0 seconds, it wouldn't have done any welding. So both of them would have a start at the origin at 0, 0. And so again, in step 2, it says at 0 minutes, each robot would have performed 0 tasks, so the initial value is 0. Then it says the data for the model GNX. This robot has a greater constant rate of change. It's 11.2 compared to 10.4, so it's a little bit faster. Now down at the bottom of the triad, I had you guys copy this down a few minutes ago. The T1000, the GNX, and the third robot. So what's the, let me pull a stick here so you're paying attention. Miss Stevenson, the T1000, going back up here, what's the rate of change of the T1000? You can look in your book if you don't see it up here. What is it? 10.4. So she just looked at what they gave us here. So I'm going to put down 0.4, and you should do the same, assuming you copied this down. Okay, put up 100 points. Mr. Mason, the GNX robot, what's the rate of change for that one?
11.2.
Yeah, nicely done. Put up 100 points, 11.2. They gave us that. And then for the third robot, it has a welding rate represented by the equation T equals 10.8 W. Okay, they don't even mention a B. I mean, I could have rewritten this as Y equals 10.8X plus B. But the question is, Miss Boulay, for this equation here, what would be the rate of change for the third robot?
10.8.
Yep, nicely done. Oh, I put 1.8. It should be 10.8. Thank you for pointing that out. So 10.8. All right. So the GNX is the fastest. The actually, the third robot is the second fastest, and the slowest is the T1000. Okay, let's look at example 2 real quick. It says a square, and I think there's 1 or 2 problems like this. It says a square with a side length S is shown. We don't know what the side length is, so they just represent it with an S. The table shows, okay, the relationship between the side length and the perimeter as the side length increases. So let's look at this. If the side length is 0, well, obviously the perimeter is 0. I mean, you don't even have a square there. But if the side length is 1, remember you just add up all 4 sides, and the perimeter is 4. If the side length is 2, you add up all 4 sides, and it's 8. The perimeter is 8. So it's 1, 2, 3, 4, 5, 6, 7, 8. You guys should know how to define the perimeter. Just add up the sides. And it says this relation is a function that is a constant rate of change. It's a linear function. But the graph shows a relationship between the side length and area. How do you find the area of a square? Okay. It's length times width, okay, equals the area. So if the side length is 2, what's 2 squared? 4. And you can just barely see it right there. It's, I don't know, right about there. That would be 4. If the side length is 6, it's going to be 6 squared. What's that? 36. It's going to be 36, right about there. If the side length is 10, it's going to be 100. Okay? So this goes up exponentially, and it's curved. So whenever you see a graph that looks like this, they might be talking about area versus perimeter, okay, which would be a straight line. Okay. Example 3. I'll let you guys look at that. But let's look at the try it. I just wanted to explain this really quick, and I do want you to do it, so circle it. It says compare the properties of these two linear functions. Well, here's function 2. They give it to us here, y equals 2x minus 4. Miss Olson, in function 2, what's the slope here?
2x.
Nope. 2. Okay, the slope is the 2. Okay. What's the y-intercept? -4. Okay. So makes it easy when they give us the equation. Of course, they didn't here for function 1, so you guys will need to do that. And again, it doesn't matter which 2 points you pick. You know, if I ever see a 1 for a value, I'll always pick that as one of my values. It just tends to make things a little bit easier. So I want you to figure out the rate of change for this one and compare it to function 1 or function 2, and then the initial value, which is the b, for function 1, and compare it to function 2. You guys understand what I'm asking for?
No.
Okay. I'm asking you for the rate of change for function 1 and the b value for function 1.
Okay.
Okay. All right, page 180, key concept. It says, how can you compare two functions? Compare the constant rate of change and the initial value, which is what I just asked you to do and what I was talking about a few moments ago. The constant rate of change and the initial value. So the slope and the b. Number 2, circle that. I want you to do it. Number 3, circle that. Number 4, just below the graph. Don't worry about the explained. You can scratch that out. As I look at this graph, Miss Igo, I know it's your first day back, but I'll pick on you anyways because you're a pretty bright girl. And I don't know where you were as far as math is concerned. You may actually be ahead of us. I don't know. But looking at this graph, can you tell me if the slope is positive or negative?
It's negative.
It's negative. Nicely done. Put up 100 points. Okay, and number 5, again, I emphasized this earlier. It says, who will pay more each month? And the monthly payments, Mr. Rowland, are the rate of change or the slope. Okay? 6, circle that one. 7, I went over in detail with the previous, although I was kind of rushed with the previous video. Circle 8, 9, 10, 11. For 11, scratch out explain. You don't need to do that. 12, circle that one. Page 182. 13. Let's look at this for a moment. It says 2 athletes are training over a period to increase the number of push-ups each can do consecutively. That means in a row without stopping.
No.
Athlete A can do 16 to start and increases his total by 2 each day. B progresses, is charted at the table. And it says compare the initial values. You should all know what initial value is by now. For each, that's athlete A and B. And then the question is that I underlined, what does the initial value mean in this situation as they've described it here? What does the initial value mean? Okay, you should be able to answer that in just a sentence or two. All right, 14, I did circle that one. Higher order, the equation y equals 4x minus 2. The table and the graph shown at the right describe 3 different linear functions. Each function has which function has the greatest rate of change. Okay, pull a stick here. Rate of change. Ms. Turner, what are they talking about when they say rate of change? Thank you. Rate of change. What does that mean? What's another word? One word for the rate of change. No? Slope. Okay, that's what they're talking about. Slope. And then it says which one has the least. So you've got 3 to consider. This green one here, this equation, the one that I circled in orange, and the graph here that's circled in purple. So just to make it easy, let's just put green, orange, and purple. And I want to know the slope for each one. Okay. Circle 15 and 16. Remember, for 16, it says which of the following statements are true. There might be more than one true statements down there. Okay.
How much time do we have left, Mr. Kelly?
Not much, like 12 minutes. So I'm going to stop.